Hi, we're Shwetava, Pedro, and Noah, and we're excited to present our project using GANs to automatically generate maps from satellite imagery.
Our task definition is taking satellite images and passing them through a model to generate the map of the area. This is a visualization of our target results with inputs on the left and outputs on the right. We created a pipeline for generating our dataset. We query Google Earth Engine for satellite images and Google Maps for map images. The images are from corresponding lat-long pairs but come in different pixel meter resolutions, so we transform them to be the corresponding scales.
We made a thorough survey of the task and tried 3 different models. The first model is a conditional GAN in which satellite images are encoded in a low-dimensional embedding. This is nice because it affords a latent space to interpolate over and hopefully find disentangled representations, as well as a more natural way to later add custom features to the vectors. The second model treats the task more like per-pixel translation or coloring by passing in the whole satellite images directly to the generator. In the literature, there are nice results in satellite-to-map translation with cycle GANs. An alternative to dealing with cycle consistency loss is to use a flow model for generation. We trained a GAN with a real MVP generator.
This diagram shows the architecture of our first conditional GAN. The satellite image is passed through an encoder for a lower dimensional embedding, which is appended with noise. This is the input to the generator. The discriminator is fed either a real or a generated map and has access to the satellite image embedding in its final layers. This diagram shows our best model, where the satellite image, in contrast to the previous one, is fed directly to the generator. The discriminator is fed a satellite image concatenated with either a real map or a fake map along the channel axis. To improve the results, we also added an L2 reconstruction loss. We also added a style loss to reduce the high-frequency artifacts from the satellite images. The style loss is as presented in Gattis et al. In summary, our training losses are the discriminator loss, the non-saturating generator loss, the reconstruction loss, and the style loss.
Let's get to the exciting part. Here are some results generated by our best model. These were randomly picked from the test set. The ground truth is on the left and the generated samples are on the right. Or are they?
You played yourself.
We see that the model was able to learn the roads and water fairly well. The generated images actually include more detail from the satellite than is provided in the maps.
In conclusion, the generator with an embedding does not manage to learn proper embeddings in time to fool the discriminator. The real MVP generator didn't show satisfying preliminary results on the MNIST sanity dataset. We get great results training without an encoder. This is probably as each pixel has more local information around its receptive field. Future work includes using more channels such as infrared for training and doing hyperparameter tuning to refine the architecture. Pre-training the encoder as part of an autoencoder might allow us to then interpolate over the learned embeddings or add custom features such as population density. Our pipeline also allows us to combine any 2 datasets in Earth Engine or Google Maps, allowing us to extend to more translations such as elevation mapping.